In this lecture, we're going to talk about topic modeling. So what is topic modeling? Well, it's a process of automatically identifying the topics present in a text corpus. So what it does is it derives the hidden patterns among the words in the corpus in an unsupervised manner. Now, topics are defined as a repeating pattern of co-occurring terms in a corpus. Topic modeling can be described as a method for finding a group of words, i.e., a topic, from a collection of documents that best represents the information in the collection. As the name suggests, it is a process to automatically identify topics present in a text object and to derive hidden patterns exhibited by the text corpus. Thus, it assists in better decision making. Now, topic modeling is different from rule-based text mining approaches that use regular expressions or dictionary-based keyword searching techniques. It is an unsupervised approach used for finding and observing the bunch of words called topics in large clusters of texts. So what a good topic model does is it takes words like, let's say, health, doctor, patient, hospital, and assigns it to the topic healthcare, and takes words like farm, crops, wheat, and assigns it to topic farming. Now, topic models are very useful for the purpose of document clustering, organizing large blocks of textual data, information retrieval from unstructured text, and feature selection. For example, the New York Times are using topic models to boost their user article recommendation engines. Various professionals are using topic models for recruitment industries where they aim to extract latent features of job descriptions and map them to the right candidates. They're being used to organize large data sets of emails, customer reviews, and user social media profiles. There are many approaches for obtaining topics from a text, such as term frequency and inverse document frequency, TF, IDF, which we've talked about in this course, non-negative matrix factorization techniques, and LDA, which is the most popular topic modeling technique, and in this article we are going to discuss LDA. Now, LDA assumes documents are produced from a mixture of topics. Those topics then generate words based on their probability distribution. Given a data set of documents, LDA backtracks and tries to figure out what topics would create those documents in the first place. So let's get right into it and do an example. So I'm going to first copy and paste a bunch of sentences, and each of these sentences is tied to a specific document. As you see, there's 5 different documents. Each document has 1 sentence. So what I'm going to do now is I'm going to create an array out of these documents, which is called a corpus. So to do that, I'm just going to type in corpus equals, and then in those square brackets, we're just going to put doc1, comma doc2, all the way to doc5. Now, what we're going to do is we're going to prepare our corpus to be used in LDA. We're going to use the same functions that we wrote before. So I'm going to copy and paste that whole part. And what we're doing here first is we're creating a dictionary from the data, then we're converting it to a bag of words corpus. We've added some comments there for you guys to help you out in understanding some of the code, but as mentioned, these functions were used in prior lectures. So what the LDA model discovers is the different topics that the documents represent and how much of each topic is present in a document. Now, Python provides many great libraries for text mining practices. GenSim is one such clean and beautiful library to handle text data. It is scalable, robust, and efficient. And the following code that we're going to show you shows you how to convert a corpus into a document term matrix. And again, I'm going to do a little copy paste here, and we have added comments to explain each of the lines of code and what's being done. So first, we're simply importing the corpora and models module from GenSim package. Then we're building a dictionary where we're associating a word to its numeric ID. In prior lectures, we've also done this. The next step is we transform the collection of texts to a numerical form. The next step after that, we build the LDA model. We are asking LDA to find 10 topics in the data. And then we're printing the first 10 most representative topics. And here's what you get from that. Now, since we trained and built our LDA model over the 5 simple sentences, whenever we want to detect the topic of a new sentence or text, we'll at first prepare the text and then push that into our model to get a topic. So let's try to predict a topic for a new sentence. To do that, I'm going to type new underscore sentence equals, in double quotation marks, my wife plans to go out tonight. The next line, LDA underscore model dot get underscore document underscore topics, opening parentheses, dictionary dot doc to, an actual to, BOW, opening parentheses, new underscore sentence, dot split, opening parentheses, closing parentheses, and 2 more closing parentheses. All we've done with that bit of code is we've split the sentence to create a list of tokens. And you will notice that the 5th topic, remember how we created 10 different topics? You'll notice that topic number 5 has a higher number, 0.699. So that means that it happens to be the most relevant topic for the sentence, for the new sentence that we added. And finally, we can also use the LDA model to find similarities between documents. GenSim offers a simple way of performing similarity queries using topic models. So I'll type in new underscore sentence equals, we are going to play soccer with the kids. The next line, from GenSim import similarities. Next line, LDA underscore index equals similarities dot big M matrix similarity, opening parentheses, LDA underscore model, opening square brackets, numerical underscore corpus, closing square brackets, closing parentheses. And then next line, BOW equals dictionary dot doc to BOW, opening parentheses, new underscore sentence dot split, opening parentheses into closing parentheses. Next sentence, we're going to perform some queries. So similarities equals LDA underscore index, opening square brackets, LDA underscore model, opening square brackets, BOW, closing square brackets, and another closing square brackets. And then we're going to look at the document similarity scores, print, and then we're going to pass similarities. So as you see there, the output, the highest score is about 0.36, and it belongs to Doc 3. And Doc 3 is kids are playing football in the field and they seem to have fun.